Okay, ladies and gentlemen, just a quick review of operations with polynomials. A little bit of terminology first, then we'll dig into the operations. A term is the product of a number and one or more variables raised to whole number powers. So a term could just be actually a number, like 7. Term actually could be a number times a variable. And the variable, we can give any exponent we want. So a third example of a term may be negative 4y cubed. So these are examples of terms. Polynomial is a term, so it could be just one of these three, single one, or the sum of terms. We know sum means add, so we could write it as 7 plus 5x, for instance. Now we're going to take a closer look at polynomials. By the way, something to keep in mind, what number is x? Hopefully, you know that in a polynomial, x could be any number. Okay, constant. A constant is basically just a number. So 14 would be an example of a constant. Negative 2.7 would be a constant. Oops, and these belong down here. Constant is just a number. Sorry about that. Next, a little bit more specific with polynomials. If we have a monomial with the prefix mono, we know that we have one term in that polynomial, so maybe 2x. If we have a binomial, we know bi is the prefix for what number? 2. And so a binomial would be a polynomial with 2 terms. So here's an example. We'll take our 2x, our single term, and we'll write 2x plus, and let's put in another term here, x squared. And then the final one here is a trinomial. What is tri the prefix for? Hopefully you saw it was the prefix for 3. Hopefully that's what you recognized. And so we need a polynomial with 3 terms. I'll abbreviate right there. With 3 terms. And an example, maybe 2x plus x squared. And we need to add another term, minus 5. Okay, so a little bit of terminology that'll be helpful. Let's go ahead and move right on. What we've got next is called the degree of a polynomial, and degree will be important to understand because that helps us figure out the look of the graph of the related polynomial function in general. So degree of a polynomial, we get the degree by taking the highest exponent of the variable in a single variable polynomial. For instance, suppose that we've got x cubed plus 2x squared plus 8. What's the degree going to be? Think about it. Well, hopefully you figured out that this has degree 3. Why? Well, here's our exponent for x of 3. Here's our exponent of x for 2. There is no other x factor in the problem. X doesn't appear in any other terms. And so what is the highest exponent? Well, that's got to be the 3. Here's another example. Suppose we've got this. I want you to pause it and try to figure out the degree of that. Okay, hopefully you figured out that the degree was what number? Hopefully you got 4. We look for the greatest exponent. Here, this x automatically defaults to an exponent of 1. We don't even need to write it in, but we know it's a 1. Here we have a 4. Here we have a 2. 4 is the greatest number, so it's a degree 4. Why do we care about the degree? Like we said, it gives us clues on the graph of the related polynomial function. In other words, if you had y equals this, that biggest exponent of 4 tells us a lot of information about what the graph may look like. Let's take a look at a little bit more with terminology. If a polynomial is degree 1, it's called linear. If a polynomial is degree 2, it's called what? Hopefully you chose the word quadratic. And if it's degree 3, it's called cubic. Oops, sorry about that. All right, now we're to the main thing. And our main thing here is to add or subtract polynomials. So let's take a look. Suppose we need to go ahead and add these. I want you to give this a try. So pause it, give it a try. See what you remember. Okay, hopefully you got an answer of 3x squared plus 8x. Let's take a look at just one way to do this problem. What we can do anytime we add or subtract polynomials is we could go ahead and take that polynomial here, we've got x squared plus 7x, and multiply it by 1. Why do we multiply by 1? Well, when we distribute, that'll get rid of the parentheses. We'll do the same thing here. And so when we distribute, we're going to get x squared plus a 7x plus a 2x squared plus x. Now we can, for our last step, combine like terms. Here we'll put in a 1. We've got 1x squared, 2x squared. That gives us 3x squared. We have 7x and put in a 1, 1x, and that gives us 8x. And that's as far as math allows us to go. By the way, what number is x? Hopefully you answered any number. Let's go ahead and take a look at number 2. We can do number 2 similarly to number 1, so pause the video, give it a try. Okay, hopefully you got an answer of 4y squared plus y minus 5. Let's go through that. We'll multiply by 1 again, multiply by 1, distribute. At this point in time, the distributive property you should know like the back of your hand. You should know that very well. Let's go ahead and combine together any like terms. Here we can combine our y squared, so we're going to get a 4y squared. Combine together our y to the first power, we're going to end up getting y. And then minus 5 at the end. By the way, what number is y? Any number, of course. All right, now that we've done some with addition, let's take a look at some with subtraction. What we'll do is we'll skip this third one, but you can give it a try if you'd like. If you want to pause it, you can give it a try, and hopefully you got an example of negative m squared minus 11m minus 3. Let's go on to number 4. In number 4, we're subtracting, and there are a lot of ways to do this. What some teachers have you do is change your subtract to an add problem, and then switch the signs inside the parentheses. And that is a fine way to do this problem. You can do the problem that way, and it will always work. What I do, though, is I teach a slightly different way. I teach basically the same way as the addition. And so what we're going to do is multiply by 1, but we'll make sure we distribute the negative 1 to this trinomial. If we multiply by 1, we're going to get 5f squared minus 2f. Multiplying by negative 1 minus 3f squared minus f plus 4. And notice the distributive property, of course, gets rid of the parentheses up here. Now combining like terms. We're going to end up there getting a 2f squared. Combining these right here together, we'll insert a 1. We have negative 2 minus 1, and so that will be a negative 3. By the way, when you're combining these two together, you get a negative 2 minus 1. If you have any concerns about negative 2 minus 1, you can always do that on your calculator. So you should never, ever get that wrong. And then plus 4 at the end. I want you to try number 5 the same way. So pause it. Do your best. Okay, for number 5, hopefully you got a final answer of negative 3x minus 9. Again, negative 3x minus 9. Let's go through that. Putting a 1 here and a 1 here and distributing. And of course, you realize that when you multiply by 1, this all comes straight down. Okay, and that's a shortcut that, of course, you can keep in mind. When we distribute the -1, each term has its sign on the left changing. That's a property of multiplying by -1. I know many of you can do this step in your head. Last, let's go ahead and see what happens with the x squareds. These drop out. Then we're left with the x to the first power terms combining -3x minus 9. So the answer, -3x minus 9. Sorry about that. Let me move that up a little bit. All right, ladies and gentlemen, do your best on your homework.